Right, before we get started, read this. Read it? Okay, cool. No need for an introduction if you watched the previous episode, let's just jump right in. So, what is biodiversity? It's essentially everything. Every form of life, the genes that give them their specific characteristics, the diversity in their species, the sins they committed, whether or not they wear hats, all that jazz. I might have to split this into multiple parts, I know you people can't concentrate for long. There are a couple of ways to measure biodiversity: species richness and species evenness. Species richness is expressed as the number of species of a particular group for a habitat. So for instance, the Amazon has 1,300 species of bird, the UK has 574, and Antarctica has like one, and even that one's trying to move to the UK. Species evenness is also a factor, because if you have a high population of one species and like 3 members of the others, that's not really that diverse. The diversity index uses both of these and sucks all the fun out of biology by mixing it with maths. So these species exist, but most of them hate each other. After all life is just a constant competition. We managed to win it by killing the other Homo species in gigantic genocides. Homo. Come on, seriously? But for the species who aren't organised enough to commit genocides, it's just a matter of adapting to a niche in their environment and sticking with it. Let's take the example of red squirrels and the bastard grey squirrels. The grey squirrels came to Britain from America and immediately started outcompeting the red squirrels, but the red squirrels just about managed to survive because they found a niche that worked for them. Upland coniferous forest. They can eat the seeds of the pines that grow there and actually digest them, whereas the grey losers can't. In the presence of a superior species, the only chance of survival is to find a niche that the chads can't deal with. Once you're in, you adapt to your niche. These aren't always physiological adaptations, like digesting the surrounding plants. They can be anatomical, like cacti having spines to ward off animals, or behavioural, like sheep learning to ignore sounds that aren't important to them, or educational video creators claiming that they don't care about viewership. In actual fact they do, but they just don't want to tell you because they don't want to seem desperate. Please subscribe. So the species just go to the niche and then work out how to adapt? No, you idiot, sit down. It's all done slowly, through the wonderful way that all specialisation is caused: natural selection. So how evolution and natural selection works is pretty much common knowledge now, but just in case we'll run through it. Let's take Darwin's finches as an example. They all had a common ancestor, which was just a regular old finch, probably came over to the Galapagos from the mainland. After deciding this place seemed nice enough, they stayed and moved across the island, which has multiple species for them to feed on. Some had fruiting plants, some had a bunch of insects, some had cacti, you get the picture. The problem was the old classic finch beak wasn't brilliant when it came to eating these. It was good enough, but they needed something better. This is where the random nature of gene mutation comes in. New mutations happen spontaneously in individuals that can then give them different phenotypes, or physical characteristics if you're a bit slow and you're having trouble keeping up. So, some of these finches would get different phenotypes, which would then cause different beak shapes. Now, I'd just like to emphasise something here. These adaptations are not intentional. There is no force acting upon these finches apart from selection pressure and randomness. No God, no Vishnu, not Darwin himself, nothing but the cold, unfeeling absurdity that is the world we live in. It's great. So, back to the finches. Some of the random mutations actually turn out to be beneficial, but only in the right surroundings. Take these guys with their massive beaks. Absolutely terrible at eating insects that live in trees, but bloody brilliant at crushing seeds. So, if this mutant freak hatches in the area where the only food is tree-dwelling insects, then he'll probably die without children, because he's ugly and stupid and he can't eat the food. The main reason being the food. If he doesn't find a mate and have children, then he doesn't pass on his freakish mutant genes onto the next generation. But if a mutant freak with a massive beak is hatched in the area with a bunch of seeds that are super hard to break, and suddenly he's the man, he's getting mad food, barely struggling at all, and he has his pick of the pussy. Actually, cloacae. Cloaca? Cloacas? I don't know. This means that his mutant genes are passed on to his children, who are then great themselves. They then have a bunch of cloacal kisses, and then have a bunch of kids themselves, and so on. More and more of the population in the area where there's a bunch of seeds have these massive beaks. They've evolved, fitting into their niche much better and thriving because of it. The alleles that cause these massive beaks become more prevalent in the population, so soon pretty much everyone in New Seedland now has one. Eventually there's so much inbreeding with these guys that their genetic makeup is so different to the old version of the finches that they can't breed fertile offspring. The massive beaked finches have become their own species, separate from the original. Right, that's good enough for now. Part 2 coming out as soon as I can be asked to make it.